Okay, so on page 17, you'll see some graphs. And when we move on to the next page in a few minutes, you'll see a combination of relations and graphs. So right now, up until this point, we've just been dealing with ordered pairs, a set of relations. And then we picked out like the domains and ranges. Now you cannot do that and list every individual point on a graph. I mean, there's so many points on this graph. I mean, even including decimals, there's no way that you could actually, list every single point on this particular graph right here. It would be impossible. So what do you do with graphs that are continuous? Like you can tell this one continues on forever. Okay, that's our lesson today, because you cannot list them like we did if you have a set of numbers or ordered pairs, where we could actually list them in numerical order. So what happens when they look like this? So that's our lesson today. So I want you to put a title here. This is called a discrete graph because you can see it has endpoints. Okay, and they actually give you the coordinates of the endpoints. So you see those endpoints. So this line does not continue forever. This one is a continuous graph. Okay, and what gives it away are the arrows. You can see it extends on forever and into infinity. So when you have a discrete graph, what you need to figure out is what is the smallest x value, what's the largest x value. So x's are our domain, so now we're going to actually figure out how far will our domain spread. That means we're going to have like an interval. Does it go from this number to this number? Okay, so remember when we wrote our inequalities, our compound inequalities, and we wrote our smallest number first? So our smallest x value is -6. And our largest x value is -1. Okay, you can get that right from here. Okay, you can see it right on the graph. They just simply read the coordinates to both endpoints and they got the smallest x, the smallest y. Now, when you do this, you will not have this box here. Okay, so this is really for me to just give you an explanation as to how you figure it out. But you notice on the next pages, you're not going to see this box. So these just help you to kind of organize and get your thoughts together. Like, what am I looking for? So this is more for instructional purposes. But you can definitely make the box if you want, or just know that you need to find the smallest and the greatest numbers so you can put it in set builder notation. So when I put this in set builder notation, I start with my smaller number. I'm going to say x such that, because we're dealing with our domains first, -6 is less than x is less than -1. And again, your smallest number is first, and your larger number is next. Okay, same like we wrote set builder for our inequalities. Now, the reason why I didn't do less equal, because remember we always use less than symbols when we're doing between two numbers, is because these dots are open. Okay. We're going to do another one in a few minutes, which is the fourth one down here, and the dots will be closed, so we will put an equal sign. Okay, so since the dots are open, it's just the less than symbol, not the less equal symbol. Let's take a look at the y values, and since they're already listed here for us, we can clearly see which one is smaller. So that's going to give us -5. And the larger y value is 3. So now we put it in set builder notation. And of course, we're going to say y such that -5 is less than y, which is less than 3. Now you can put yours under the graph, okay, because I'm able to erase and move things around. So you might want to put it somewhere where it's not going across the next problem. Okay. All right, so that's called a discrete graph because you have endpoints. Let's look at this one right here. Here's another discrete graph because I can tell the graph stops. It has endpoints as well. So let's do another discrete graph. So first thing we got to do is identify what is the smallest x value. Okay, looks like it's going to be this point right here. That's the smallest x is going along the x-axis, which is at -2. And then the largest x looks like it stretches out over here, which is number 7. So I'm going to say x such that -2. Now I'm going to say equal, because these dots are closed, is less than or equal to x, which is less than 7. All right, so see if you have any questions about how I got the numbers. I'm sure you're okay with putting in set builder because we've done that before. Start with your smaller number to the larger number. All right, yes, make sure you add the equal there as well. All right, so let's do our y values. So what is the smallest y? All right, it's right here, okay? That's -3. And what is the largest y? Yep, right here. That's going to be 6. So we put it in set builder notation, y such that -3 is less than or equal to y, which is less than or equal to 6. All right, does that make sense? Okay, so again, we cannot write all the x's between -2 and 7 because we're not just dealing with integers. Okay, you could have -1.89. I mean, there are more numbers than just integers and whole numbers. So that's why you just say the x's range from -2 between and including for this one, -2 to +7. All right, now let's look at some continuous graphs. That means graphs that go on forever. All right. So graphs that go on forever, if you take a look at the arrows here, it tells you it continues forever and ever and ever. So that's really going to be for the x's. If I stretch this x all the way out, and I stretch these all the way out, and I continue to go out, it's going to eventually cover the entire x-axis. So you got to kind of visualize that this just doesn't stop here. It just continues, and as it continues, it's going to start getting wider and wider on each side. So that means you're stretching across the entire x-axis. So we just say from -infinity to +infinity, okay, because that's going to be everything, okay? So that means all real numbers. So remember when we wrote all real numbers before, we say x such that x is an element of all real numbers. Because that's going to be all the x's as that graph continues to grow. Now let's look at, now we can't say the same thing for the y values because I don't even have any y values down here. Okay, my y values actually have a starting point, and then they continue to get bigger as the graph gets bigger. So this starting point is at 2 for the y. So I will call that my smallest y, but then it goes on to infinity. Okay, because as this graph continues to grow, the y's are getting bigger. So to write that one, I'm going to say y such that y is greater than or equal to 2. So it starts at 2, and I'm using greater than because it's getting bigger. Because here's 2, 3, 4, 5. It's going up, 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 up to infinity. So we use greater than or equal to. My fault, I put an x instead of a y. All right. Any questions? Okay, so those are our ranges. So if you're asked to find the domains, you're going to say x such that x is an element of all reals. For the ranges, y such that y is greater than or equal to 2. All right, let's move on down to the other continuous graph. And this graph here, guys, it continues on because it has the arrows. So, of course, it'll keep doing that same pattern all the way across on the right and all the way across on the left. So that means it's going to stretch across the entire x-axis again. So we're just going to simply write x such that x is an element of all real numbers. And if you want to put from negative infinity to positive infinity, that's what it's doing. Okay, because it's going across on the left and the right. Now notice the y's are not doing that, okay, in this picture. So the y's actually have a high number at the top and it has a low number at the bottom. Okay, it peaks at 3, that's the largest number, and then it goes down to -3. That's the smallest number. That's all it's doing as it keeps repeating this pattern. So it really only going from -3 to +3. So we're just going to say y such that, and we really could write this two different ways. We could really say y such that y equals 3 and y equals -3. Okay. However, there are some y's in between here as well. Okay. So let's be a little bit more exact and say y such that -3 is less than or equal. Now, why am I using less equal though? It is a continuous graph. That means there are no breaks in the graph. So there's no openness in the graph. So that's why it is equal. So we are going from -3 to +3. Okay. So this would actually be the correct answer that you would want to write. All right. Now I will go over where you're going to actually have like one value for y, and that will be for a horizontal line. So I think I have an example on the next page. Any questions before we go to the next page? Okay, let's move on. So this is what you guys already have been doing. You've been able to list the ranges and domains if you're looking at a mapping or a table. Okay, so that's 1, 2, 3, and 4 are things that we have been doing already. So you can list individual points like this right here. You would actually write the coordinates for each. So let's go ahead and do that. So this would be at what, -3, -1, 0, 1. This would be 3, 0, 4, 5, and 5, 1, 2, 3, 4, 5, 4. So for individual dots on a graph, you have to read the coordinates yourself and then put the domains in order and the ranges in order. So those you already know how to do, 1, 2, 3, and 4. So let's continue with 6, because that's one we haven't done, which is like a horizontal line. So here is the x-axis, here's the y-axis. So this line continues to go across the x-axis. It's going to really follow the x-axis. And notice now you don't have that box under here. Okay, so you got to kind of just, make sure you know the process to take. Well, if it's going to follow the x-axis, it's going to be all real numbers. All right, now for the y's, well, the y's stay at one number. What number is that? Okay, what's that number right there? Should be 4. So the y's actually stay at 4. They don't even move. So now you can say y such that y equals to 4. It's not moving. It's not going between 4 and another number because it is a horizontal line. It is actually staying at 4. Okay. All right, I'm going to do number 5. This is like an upside down V. Okay, so remember we just did a V that was going up in number 2 on the other page. So this is going to continue to go down. And as it continues to go down, it's going to stretch across the entire x-axis again. So we're going to say x such that x is an element of all real numbers. Okay, but again, I cannot say that for the y's. Okay, the y's are not all real numbers because there are no y's up here. Okay, so anytime it dips or it has like a point where they meet, then that's where you want to start for your y's. So my y's actually start at what number? At 5? Is that a 5? All right, so it actually starts at 5. And then I got 4, 3, 2, 1, 0, -1. So it's getting smaller. So I'm going to say y such that y is less than or equal to 5. I didn't say greater because the y's are actually getting smaller because it's going down. It's not going up. Okay, so you just gotta look at the graph and you can tell what's happening with the numbers. All right, so you will finish this page. And again, these are just ordered pairs, so you know how to take them and put them in numerical order. But what happens when you get to 10, 11, and 12? This is where you actually have to put on the graphing calculator. Okay, so for 10 through 12, you're going to actually graph it on the calculator so you can see a picture of what it looks like. Okay, you can sketch it if you like. All right. So what I would do is just put it on the calculator, graph it, make a little sketch, and then they'll look like the ones above, and then you can figure out what the domains and ranges are. I'm going to do number 11 with you. So if you would, go ahead and hit the y equals key and put in negative, hit clear anything that's in there. And then put in -2x and then graph it. Okay, so it looks like this. All right. So I'm going to go back here and I'm just going to draw a graph. Okay, just sketch it. Okay, that's what it looks like on the graphing calculator. So this is what we call a slant line. And all, write this down, continuous, and this is a continuous, slant lines they will have all reals for X, that means domains and ranges. So as this graph continues to, spread up and down, it's going to cover not only the x-axis, but also the y. So you're just going to say x such that x is an element of all reals, y such that y is an element of all reals. So that means I don't care if the line, where the line is slanting, okay, all slant lines going this way or this way. And you might want to draw some more slant lines because it's for every single slant line. For all slant lines, you're going to have all reals for both. Okay, you won't even have to think about it. Okay, if you see the line is slanted, automatically it's all reals for both. All right, so for classwork, you're going to do finish up this page here, the ones I did not do, and then on this page, which is page 19, okay, you're going to also do this page here, okay, after you finish your quiz. Just to give you a hint for number 20, try to make sure this one kind of goes to, it's not an exact number. You want to get like your largest X and your largest Y. The Y's are pretty prominent here on the graph. You can pick out the largest X. You can pick out the largest Y's. They come out to be integers. But the X's, let's go ahead and do that now. 1, 2, 3, 4. Looks like the x's on this side go to 5. But over here, 1, 2, 3, 4, it looks like it's negative 5.5. Okay, it's not at negative 6 quite, but it's not at negative 5. It's like in between. So when you drop this down here, it's going to be like negative 5.5. So I've kind of given you the x values. Now all you got to do is figure out your least and greatest y values, and then you'll have that one. Okay.